Because cosine functions start at the maximum and then go down like that. And if your timing had been impeccable in the lab that you did this past week, or last week, you could have started it when it's right at that peak, you know, because it does this 60 times a second. You just have to time it down to the 10,000th of a second. You would have nailed it. Was that
Easy peasy.
Yeah. And I assume that because you didn't, you just wanted the challenge of having everything just a little bit off. I appreciate that. Other questions right now?
So the initial question, if you had given us, like drawn this RLC circuit for us, was just what is the formula for the impedance for
Yes.
this circuit? So
And-
we're plugging in numbers from here?
I'm about to give you numbers.
Oh.
One other comment. This is the formula for impedance that I believe is at the end of the chapter, of whatever chapter we're on now. So just recognize this formula for impedance, again, is only valid for the RLC series circuit. Any other circuit, don't use this formula. All right, let's do some numbers. What are the chances I have good numbers written down? Not very much. What are the numbers we used last time for R and C?
50 ohms for R and 30 microfarads for C.
And L. We'll start with 2 millihenries. I might change that. All right, so first off, if I gave you numbers like this, and question, the question would be a series of questions that help lead you through it. So let's give a little bit of information about the power supply. So let's go with something different. Let's go with 100 hertz frequency as opposed to 60. And let's say that the RMS value of the voltage for the power supply is let's make it small. No, I don't want that small. Let's make it 100 volts. Let's do 100 and 100. All right, so starting out with what is epsilon sub naught? There's enough information for you to figure out what the maximum power voltage from the power supply is going to be.
It's all right, 141.4 V volts or frequency.
141.4 what?
V
Volts.
volts. Okay.
Okay.
Yeah, okay.
I can do it.
Just that times the square root of 2.
Yep. Maximum value is the RMS value times the square root of 2. All right, so the frequencies, this thing oscillates back and forth 100 times a second. So in 100th of a second, it has done a sequence. What is the angular frequency?
628.3. Radians per second.
Now, when you picked up the calculator, was it, you were thinking I wanted more decimal places, or were you just, there was that brief moment of the units?
I was wondering if you were wanting more decimal places.
Okay.
Because I knew it was radians per second, like the back of my hand.
I don't know, if there's a dependence there, if we need to find a 12-step program for you.
Sure. Yeah.
After I do a bunch of calculations, I look at the calculator for more things that I know it can provide. But there's still that impulse of, it's there somewhere.
Mm-hmm.
All right, so we got those two. Let's go ahead and say that it starts out at the maximum, so therefore it's sort of implying that phi is equal to 0. That, we'll put a little PS there just to specify it's for the power supply. Specify, actually, it's the voltage for the power supply. So right off the bat, I have an equation for the voltage from the power supply, either one. And so we have 141.4 volts times the cosine of, just did it, 628, and now I'm going to be off screen there, so let's move it over some. And that green is making me sad. 141.4 volts cosine of 628.3 radians per second times that. So I now know how long this phasor is, at least, whatever, or however long it is, has to represent 141.4. Right, so as we're sort of guiding you through this, what is the value of x sub c and x sub l? Oh, and while I'm thinking about it, Freddie, did you leave your calculator?
I think, yeah, that's what I'm looking for.
There we go.
I'm tracking you down, but Ty and Connor?
That's you.
That's you, okay.
It is, it's from the pawn shop, that's why.
Ah, good. So I'm tracking you down, and I saw that, and I thought, well, I wonder if it's one of Miss Sassen's students. Sorry.
Yeah, I was looking for it earlier.
For x sub c, I got 53.1.
Units?
Let me drop this for a second.
I have been off by a factor of 6 decimal places. What did I do wrong? Like I got 0.000053.
Did you not do microfarads?
Oh yeah, no, I didn't convert that to farads.
Let me think for a second.
And I know Harrison's the one struggling right now. I don't know if anyone else is struggling just to try to beat him. But Harrison, if you want to tag somebody, feel free to.
This is on me.
It's on you?
The class is
Okay.
depending on me. I feel like we did, hang on, let me just. Oh,
Yes.
yeah. I remember it was something funky, but then it ended up equaling ohms.
I actually didn't realize that's what you were searching for. I'm sorry. I could have beat you.
Well, you didn't, Anna, so.
It's my turn.
All right. X sub L. This is the one where I might change the value there because I'm trying to do it in my head. Having issues.
.00006. I put it in microfarads.
That does not seem right.
Two, which is our,
It-
oh, we have to convert this
Yeah.
millihenries, don't we?
Yeah.
Yeah.
Got it, units.
One 1.26.
Yeah, I wanna make that something different.
That's milli, what? Wait,
Millihenries.
of course. Duh, yeah. How could I possibly even get confused like that?
Don't be hating on Henry.
Yeah, that, I was about to say the same thing. Took the words right out of my mouth.
Great minds think alike.
Yeah. Yeah.
Nothing.
Alright, that was, sorry. What was XML?
1.26.
Alright, let's see, I want something different then, so let's make this, so that was 1.26,
Oh,
so let's make that 80 millihenries.
Uh-oh, we're up in the Henrys.
Not even, there's still less than 1 Henry.
50.3.
Say it again?
50.3.
60.3?
50.
50.3, ooh, that was closer than I wanted. What the heck, we're going for it. 50.3. So I have X sub C, so ultimately V sub C will be just a little bit bigger than V sub L. Because they have the same current. All right, so now we can find the impedance. And plug and chug.
Could someone take a moment to read off the calculator that what they typed in to get the 50.3, because I'm not getting that number.
Yeah.
628.3
Uh-huh.
times 80 to the negative third.
10 to the negative 3.
I heard you talking about microfarads earlier when you were doing this, and that is not involved. If that is.
Yeah, because you've got capacitance up there.
It was microfarads and millihenries.
Oh, I see my mistake.
Do you spell
Okay.
Henry like
Thank you.
H-N?
HN? I don't spell Henry that way.
Where have you been?
Guys!
The cool people.
HN?
H.
No vowels.
Harrison. Okay, just like a regular.
Just like the regular.
And plural, you just throw an S at the end of the Y, there's no IES going on.
No, that's actually.
I actually like that
That's a
better.
genuine question.
I would spell it that way if I were doing plurals.
But I bet the physics people fight over it. Don't they?
Yeah, because of YS would mean it.
Is it-
Because it's not
possessive.
officially a
That's
proper noun, it is an improper noun.
It means if you did an apostrophe S, that would mean that.
It's a
It's
possessive.
possessing.
Henry.
That's
a
what
It's either
Possessive.
possessing or you
Yes.
Well, like
cut
when you
letters
say
out.
days, that's not possessive, you just
Yeah.
pluralize
Yeah,
days,
you
it's
don't
just
need
a
the,
Y.
if you didn't put the
Yeah,
apostrophe
exactly.
in there,
Yeah.
then it would just be like
Yeah.
it's.
Yeah, but days has a vowel right in front of the vowel, right in front of the Y. That's the big difference.
Situation, I appreciate the answer.
That-
I will remember the unit better because of this conversation.
Yeah, me too.
But the physicists just will write the letter H and they won't worry about the rest of it. Okay, so we're now down to figuring out impedance, and this is just plug and chug. So Z is equal to the square root of 50 squared plus 53.1 minus 50.3 squared. So it'll be something really close to 50 in the end. Matter of fact, we said, well, 50.132. And the realizer is
50.08.
units.
Oh, panic.
For impedance? This is for impedance?
Yes.
Ohms.
When in doubt, if you blank out.
It's basically a resistance equivalent. So notice in our particular case here,
If I didn't write it down.
the reactance from the capacitor and the reactance from the inductor are almost canceling each other out. So we're getting maximum current here. or getting close to maximum current. If they actually canceled each other out completely, then we would get the maximum current coming out of the power supply. And so if I had an adjustable capacitor or an adjustable inductor, I could then tune, I could throw a dial in there and I could just tune it to whatever current I want. Very crudely, this is the essence of a radio. I mean, you're adjusting a little knob there to adjust how the current is, where you're getting maximum current. There's a lot more detail I just skipped over, but.
Yeah, I was gonna say my mind is blown, I suddenly understand radios. Doesn't this, it all, you know, Z's and the Henrys.
Suddenly you
Some-
throw Henry's in there, and it just all makes sense, yeah.
Sometimes there are practical applications for physics, sometimes.
Sometimes.
yeah.
All right, just for the sake of, I don't want that too small.
I had a quick question.
Yes,
I think you might have touched on this, but why is the phi VPS equal to 0? Is that something that's given, or is that something we can determine
that's something that was given.
that is given? And will that always be given?
I'd say always, but.
Sure, we don't deal in absolutes here. Only sits
Only
deal in absolutes, even though that's an absolute.
Most of the time on tests when I've done
We don't.
done the AC circuit problem, yes, I've made that 0.
Okay, gotcha. Okay.
Could you provide one example of the phrasing if it weren't 0? Because it seems like there's 3 different ways that you phrase that. I just wanna like recognize the language, it helps with blank out, so.
I could do that the initial voltage of the power supply was at a minimum, at time is equal to 0. Which, and then you get into an issue of, all right, is a minimum negative 141.4 volts, or is the minimum 0 volts? So I probably have to be more specific.
Yeah.
Technically, when I said minimum, I was thinking in my head, negative 141 was the initial value.
Right.
So my phase was 180 degrees off. So phi would end up being pi. No, wait, sorry. So you'd want, yeah, phi would be pi. Because when time is equal to 0, this term drops out, so the cosine of phi phi is pi radians. This would be negative 1, which we're looking at the minimum.
Okay, thank you.
If I said, remember that the instantaneous value is the projection onto my horizontal axis. So, if I said that, assume that the initial voltage from the power supply at time is equal to 0, that the voltage is 0, recognize that that's not enough information. Because that could mean that my voltage from the power supply at time is equal to 0 is either pointing that way or that way. And there's a difference between those two phases. So I'd have to give you more information. All right, I'm about to change this problem slightly. I'm gonna tell you X of L and let you figure out what L is. So if X of L is 70, what is my inductance?
Point one?
0.1?
Yep.
So this would be 100 millihenries or 0.1 henries. Okay, so working with that, my impedance, that should be a 70 there. What is my new impedance? And then we're gonna work the rest of the problem with this number. Should be more impedance than we had before.
Yeah, 52.8.
Not much more. 52.8 ohms. All right, so I know the impedance now. I know what the overall resistance equivalent of the circuit is. I know what my maximum voltage is coming out of the power supply. What is the current? Sorry, what is the maximum current? Or how would you find it?
You're going to divide the 141.4 volts by a value in ohms. Is that correct?
By that value in ohms?
I'm not sure which value. It's by the impedance value. Yes, it is by the impedance value, yes.
Yes, using this formula right down here, that the maximum value is equal to the current coming out of the power supply times the impedance.
Okay.
All right, so what do you get?
.68 amps.
All right, so 6.28.
Or no, 2.68.
Yeah.
I wrote it down correctly there, okay.
Okay.
2.68 amperes. All the currents are the same for this problem, so